we now have the ability to generate multiple synthetic weighted images from a single sequence. So both with 2D and soon with 3D sequences, we can, by using smart count, generate as much as synthetic weightings that you need for one given clinical application, and it is customizable which synthetic weightings you will obtain. It's a zero-click workflow to produce the images, both for the technologist. Once you have acquired the sequence, it will go through the server and go directly to the PACS. And so when the radiologist open the case in the PACS, he will get all the synthetic weightings and quantitative maps that he wants to have. So this gives us the potential to have a great gain of time in our acquisition protocol, which means less time in the device for the patient, so more comfort, but for us also the ability to scan more patients a day, which is quite important given the pressure of doing a lot of exams to raise more money with the lower income that we have per exam. With that same acquisition, we can have the added value of quantitative maps and volumetric reports. And I hope with my examples that you are convinced that it's a real added value in some clinical indications. So now that we have this 3D multi-contrast sequence, we can really go a step forward. I have shown you that the MS protocol that we used with 2D smart count was pretty much the same scan time that we used before, but now that we have it on 3D, it gives us the possibility not only to remove the 2D PD and T2 sequence, but also to remove the T1 gradient echo sequence and also the 3D flare sequence, and all of that will be replaced by a single 4-minute sequence that is 3D, that can be used for reformats, and on which you will have all the sequences that you need and that you can now remove from your standard protocol. So now the important thing is you have all those complementary sequences that are on green, but you also can reduce the scan time because you will replace 3 sequences by only 1 sequence that has almost the same acquisition time. So of course, what it will not do is replace non-conventional sequence. And in our MS protocol, we kept, for example, the 3D susceptibility EPI sequence that helps us assess the central vein sign, for example. And we also kept the diffusion weighted sequence that cannot be given by synthetic weightings from the KELAS sequence. But it's already a lot of improvement, because when you go from a 17 minutes time slot to a 12 minutes time slot, then in an hour you can scan 1 patient more. So the first thing which I find very important is that now we have ability for research of doing 3D sequences that are usable with synthetic MR. So we can have in research for now, but it will soon be on the clinical practice side, a 3D sequence on which we can do isotropic voxels and reformat in every plane. And those sequences will, as the 2D examples that I have showed you, be able to generate several synthetic weightings. So this is an example of a 34-year-old female with MS, and those are the conventional data sets for you to compare and for you to see that we do not lose any MS lesion with the synthetic weightings, and additional to the regular weightings that can now replace all the regular conventional sequence. You have all those additional weightings, 3D proton density, 3D T2, 3D PSR, and 3D double inversion recovery. And we can hopefully reformat this in every plane for each synthetic weighting. So it's like that you have done 6 different 3D acquisitions and be able to see them and to help you confirm whether the MS lesion is there or not. And you can absolutely reformat it in every plane. So this is an example of a subtle subcortical T2 lesion that is very well depicted on the synthetic T2 flare. That is better visible on the double inversion recovery and the PSR, that are not additional sequences, but just complementary to use with the single 3D CALAS acquisition. So here is another example of patient to show you a variation of the sequence that is faster and that we use, for example, for meningioma follow-ups. And this is a sequence that is not quite isotropic. The reformats and interpolation makes it isotropic, but we gain a little time by doing it with a 2 mm thickness. And this is an example to display that the contrast that we obtain with the synthetic weighting is very good. In the upper line, you have the conventional weightings, and we have done it with the full gadolinium dose, but in the middle, we have done it with 1/6 of a dose, so a very low dose of gadolinium. And as you can see, with the synthetic MR generated images, we get a very good contrast, even with low injected dose of gadolinium. And those are the actual slices on which you see that with the full dose, the meningioma is very well depicted, but with the reduced dose, it is still very well visible, and it's not inferior to the conventional T1 post-gadolinium. So here's one example to display that the 3D sequences also have the quantitative capabilities. This is a 67-year-old female with gait disturbance, and you can see that she has hydrocephalus. You can see the actual synthetic weightings and the sagittal reformats. As you can see, it's an isotropic voxel that can be reformatted in any place. So basically, in one single sequence, I get everything that I need to assess both parenchyma and ventricles, and I will get for free all those segmentations and additional myelin maps. And which is very interesting in hydrocephalus is that I will have the CSF volumes quantifications. And as you can see in this patient, we have a very high CSF volume. And an additional information that we were not aware of in this patient is that the intracranial volume is also raised. So she has microcephaly, and it was a clue to diagnose long-standing over ventriculomegaly in adult. So the workflow is very important with this software, and hopefully with synthetic MR, the workflow doesn't require any additional click either for the technicians or for the radiologist. The images will automatically go through an on-premise server, and the on-premise server within usually less than 1 minute will generate everything, and it is you can set up what you need in terms of synthetic weightings, and then it will automatically send everything to the PACS. So when I open my case in the PACS, I don't need actually to do anything, and I will see the images that comes from the sequence in yellow here, and straight when I open the case, I will have all the synthetic weightings that I have set up in the synthetic server for the lifetime of the server. And when I open the case, I see all these series, so I don't need to bother generating anything. It's always available without any click from the radiologist.